So I want to give a little more intuition about standard deviation as a measure of risk. So I want you to think about two types of investments. So we're going to invest in two stocks. Let's say asset A is Amazon, asset B is Boeing. All right? And we'll say we'll have monthly investments. So RA is the monthly return on asset A. That's a random variable. RB is the monthly return on asset B. And let's just assume that the normal distribution describes these distributions. So the monthly return on Amazon is normally distributed with mean mu A and variance sigma A squared. The monthly return on Boeing is normally distributed with mean mu B and variance sigma B squared. So how do you interpret the parameters? Well, mu A is the mean of the distribution for the return on asset A. That's the expected monthly return. So if you invest in Amazon, what is the return that you expect over the month? Well, it's the middle of the distribution. So that's what mu A is. It's your expected return. And then sigma A is the spread about the expected return. So this, in a sense, measures the uncertainty associated with the investment. So if sigma A is big, there's a lot of uncertainty associated with your investment. If sigma A is small, there's not much uncertainty associated with it. Now, and the same is true for the parameters for mu B and sigma B. Now, one of the things that we typically find, so when we actually look at real data on investments in different kinds of stocks, suppose that the average return, the return that we expect on Amazon is bigger than the return we expect on Boeing. So on average, we expect to get more money by investing in Amazon than we expect to get by investing in Boeing. We typically find that the standard deviation of the return on Amazon is also bigger than the standard deviation on Boeing. So that when one asset has a higher average return, it also tends to have higher standard deviation or higher risk. And so this is, I like to call this kind of like the no free lunch principle about investing. If one asset has a higher expected return, well, you don't get something for nothing. In order to get a higher average return, you typically have to take on more risk. All right? Now, this isn't always the case, but it's generally true. So what we'll often find in data is something that looks like this. So if, let's say the Boeing distribution is the blue line. So on average, we get a 1% monthly return and a standard deviation of 5%. So the dotted blue line represents my normal distribution for Boeing. Okay? Now, Amazon, you get a higher average return, but you also have a higher standard deviation. And so that's this black line here. So on average, we get a higher return, but there's a bigger spread about the average, which means we could have there's more likely to get a bigger negative return, but it's also more likely we can get a big positive return. Okay? So, again, there's risk on the upside and there's risk on the downside. Okay? When people talk about risk, they really, I think most people are concerned with the risk of loss, so it's kind of downside risk. Standard deviation in a normal distribution is symmetric, right? So the risk on the downside is the same as the risk on the upside. So, and some people view risk as opportunity, right? So if you really care about making money, then you prefer the black distribution because there's a higher likelihood that you can get a big killing, but there's also a higher likelihood that you can get a loss. If you're willing to take the possibility of loss and you really like the upside gain, then you might prefer the black distribution over the blue distribution. On the other hand, if you're extremely risk averse, if you don't like uncertainty, then you would prefer the blue distribution. So you might tolerate a lower average return, and it's because there's lower risk associated with that.